right there, under scatter plots here. Let me see if this thing has. Okay, scatter plots are when you take, we've talked about this last year, you know how I know? I just did it yesterday with 7th grade. Scatter plots are plots or graphs that come when you graph stuff that don't always necessarily follow the straight line. For example, if I were drawing a graph that, and I asked you, you know, how, the two questions, we're going to compare the time, X is the amount of time you spent studying for spelling, and I'll make up stuff because I know none of you do, and then Y is the number of problems you get wrong on the spelling test. Okay, so let's say I asked Evan, let's say Evan was, I don't know, really doing what he should have been doing, and he studied for a spelling test. Let's make time, let's make these in increments of 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes. So Evan studied 0 amount of time, and he ended up getting on his spelling test, what color should I go with? Let's go with he didn't study, so Evan missed 4 problems on his test. Alright? Ariel, she spent 20 minutes studying and she only missed 2 or something like that. Ryan spent a half an hour studying, he missed 1. Eli spent 10 minutes studying and, well, he is a good speller, so he only missed 1 even though he spent 10 minutes. You know, Sammy spent 40 minutes studying, she missed 0. Alyssa spent 20 minutes and she missed 0 as well. Congratulations on that, Alyssa. You know, Emily spent 10 minutes studying and she missed 3. Jacob, he spent an hour studying and he still missed 4. Luke spent 40 minutes studying and she, you know, missed only 1. I don't know, Michael spent 20 minutes studying and he only missed 1. Christian spent 10 minutes studying and he missed 2. Okay, this is a scatter plot. It's called scatter plot obviously because things are scattered about. Okay, they don't always fall in a nice straight line, but when you see a scatter plot, you are supposed to look for trends. Okay, is there a trend? Question mark, which means do they form some sort of a pattern? And there is. When you study, usually the pattern is the longer you study, the fewer problems you're going to get wrong. That's kind of the trend with that. Okay, if I were looking at this, there's a trend that the more somebody studies, the fewer problems you're going to get wrong. Now, are there some things that fall outside of that, outliers or things that don't? Yeah, that's going to happen too. But you want to take a scatter plot and you want to look and see a trend. And there's only 3 choices. The trend is either, when you look at the dots, they're going to go from left to right, it's going to go up, and the slope is going to be positive of that, and that's what's called a positive correlation. Or, as the dots, you know, as the thing goes down, it's a negative slope and it's a negative correlation. And there will be times when you see no pattern at all, and that means there is no correlation. Okay? You know, something like the amount of time studying in your favorite color. It doesn't matter how long you study something, your favorite color is not going to change, or whatever it is. Okay, they have absolutely no. So you need to see that and understand that when something asks you, is there a positive correlation or negative correlation? That's what they're asking you for. Now, with that being said, we have what's called a line of best fit. Because you're going to take and analyze this data. You're going to take it and look at it. For example, this here is the age of drivers compared to how far they can see a sign. Okay, is there a correlation there? Absolutely. You know, as you get older, your eyesight gets worse, so the distance you'll be able to see a sign is going to go down. And what you are asked to do is you're asked to, in the midst of all these dots, try to find a single line that's called the line of best fit. And this is not an exact science. Okay, this is kind of up to a little bit of your opinion or whatever it is, but you want to take those dots and you want to try to draw a line through them in such a way that there's as many dots on the upper half as there are on the bottom half. You want to try to split it as much as you can equally through the middle. Okay, now this one, does that look like a pretty decent, I would say that's pretty close to a line of best fit. Maybe I should move this bottom up a little bit like this. Okay, again, it's open to your interpretation as to what it is. Or maybe this should come down a little bit. Maybe the slope shouldn't be that great, but you know, as long as you're getting close. I'm not going to, if you put your line like that, I certainly would accept it. Okay, but as long as you're looking at it and there's about as many dots on top as there is on bottom, you know, it's good. And with that, you can make predictions as to, you know, a 35-year-old person, how far should they be able to see? Well, you go straight up from 35. You know, you go up from 35 right here. Oops. Can I undo that? Yeah. You go up from 35 on the x-axis, see where it crosses the y-axis, and you can make a prediction that, well, a 35-year-old person should be able to see a sign at a distance of about what? 470 or something like 470 feet or whatever it is. You can make those predictions on that. As a matter of fact, people, you are 8th grade now, right? Yeah. You should be able to, as best as possible, you should be able to actually write the equation of that line. Okay? What would the equation of that line look like? Well, you know that equations of line are y equals mx plus b. About where does this cross the y-axis? And again, as long as you're close, you're going to be good, because it's not going to be exact. What would you say that is? About what? 5.5, 550. And probably the hardest part is you are going to have to try to figure out some sort of slope of this line. And the slope of that line, you could just simply, you know, pick a point where you think you know something here. Let's go across from 400. Let's say 400 goes right here at about 60. And find another triangle maybe. Where else? Can we get one at 300? No, let's go 500. What do you say? 500 maybe is at 30? If I drew a right triangle between those points, right here, here's my right triangle, what is the slope of that line? How high is it from here to here? From 400 to 500 is 100. Over, how wide is this line from here to here, which would be about, what did I say, 30 to 60, which is 30. So the slope of the line is 100 over 30, or 10 over 3. Y equals negative at 30, x plus 550. Now, I mean, you could use that for some data or whatever there, but your slope probably will vary a little bit based on how you drew that line. Like I said, it's not an exact science. What about this one here? Ooh, get go a little smaller than that. I was trying to figure out what this graph actually meant. What temperature Celsius compared to money? What's this? Huh? It could be your heating bill. No, it couldn't be. It'd have to be your cooling bill. How about that? At 12 degrees Celsius, which is about what temperature? 12 degrees is probably what, 50 degrees? When you get to 26, you're talking about 80s or 90s here, Celsius, whatever. So maybe this is how much you spend on your heating here. If you were drawing a line of best fit there, by the way, positive correlation or negative correlation or no correlation, positive because it goes uphill. If you were drawing a line of best fit, this one's actually a little more obvious than the last one. What would it look like? You know, you probably know something like this. Would you call that accurate, or should it go down a little bit? If you were doing it, what would you do? Maybe down just a touch? I don't know. Does that look about right to you? Okay. And again, with that, you should be able to predict some stuff here. You know, 20 degrees Celsius, whereabouts does that cross? How much money would that cost you? Somewhere between 400 and 500, probably 430 or something like that. At 26 degrees, you're way up here in the 610, 620 range. if I asked you to write an equation of that line, you would come up with something like this. Y equals, where does it cross the y-axis? At about 150. What is going to be about the slope of that line? You know, you could do this. Look, it crosses kind of right here, and it crosses kind of right here. So draw your right angle right here. How high is it from here to there? 200 to 500 is 300, thank you very much. How wide is it from here to there? What is it, goes from 12 to 22, so it is, what's that, 10? So your slope would be about 30x plus 50, positive. Was I wrong? Oh, 150. 150? Yeah, sorry. 150. How about the last one? Maybe I'll let you do that. Do that last one on your notes for me. See what you come up with. See if yours is in the ballpark of mine. And I don't remember what's this one. What's the graph of this? Positive or negative correlation? It is what? Something age and something something. What's it say there? Oh, at age 10, at age 1, it cost you $10,000 to be alive? Sure, why not? What could that be? 1, 10,000? I don't know. I should go look that up on the internet. Draw me, huh? Oh, yeah, well, it could be, yeah, amount spent at the doctor. You know, when you're born, it costs you $10,000. The way Obamacare is going, maybe that's the other side of that. You draw me a line of best fit and try to give me an equation. Do what you can. It's a negative correlation, so it's going to be negative slope. Give me a line of best fit. And again, you probably should use a ruler. I don't know what you like to do stuff. We can well, see, and again, it's more or less guessing. I would do this. I would just actually pick up a place where you say, that goes straight up from me. That goes straight up from once. You can get that point right there. You can find another place where you can go. So you go straight up from 4. Your answer probably will be different from somebody else's as far as what you're. That's probably true. It's a pretty big gap over there. Yes, no? Hopefully your line looks something like that. And again, making the triangle is a little bit on the difficult side. But one thing you could look for is when you draw your line of best fit, look at dots that actually fall on it. Because then you know for sure this goes to the 7. It has to, because that's probably why they put the dot there. Now, where does it go over here? Well, it could be 5,000. That's one point, and maybe your other point is right here. Which is what, 2? It kind of looks like it's in the middle, doesn't it? Does that look like it goes down to 2? Yes? No? Does that look like a straight line? Sure. So here's your triangle. Your equation ends up being y equals mx plus b. B is, I think 10,000 is probably your good guess. What is the slope? The slope's going to be different. My triangle here is 5 wide. How high is it? It looks like it goes from like 5,000 to, gosh, I don't know what that is. Maybe 8,500. What is that, 3,500 difference? So if you take 3,500 and divide it by 5, half of 3,500 is what? About 700. I have negative 700, but I would suppose if yours is anywhere from 600 to 900, I don't know. There's a pretty big range there. As long as it's negative and it's a pretty big number and your y-intercept is close to 10,000, that would be close. And again, you can use this to predict, if you're 8 years old, what's it gonna cost you? You're gonna shoot across there, it looks like about $4,000, whatever. Everybody get close to that? Relatively close? Evan, what was yours? Just
like 3,000, like 7,500.
Wait, this was 3,000, what?
Yeah, no,
Your y-intercept is 3,000?
No.
That one, your y-intercept's gotta be somewhere up here.
Where you at?
No, so what was your slope?
No.
What was your slope, Savannah? What'd you have for slope? Huh? Who had slope there, Calvin? So that's about 7, that's about 700. That's in the ballpark. Anybody else have something close to that? I mean, as long as when you divide it out, it's like 700 or 800 or something like that, your slope is pretty close. 25 over is a little over 600 plus, which is pretty close to 9. Smith? 590, that's not far from, as long as it's negative, you're pretty good at it. Perfect, all right, for tomorrow. Wait, what is happening?